Hi, this is Sung, the Principal and Director of Sky Academy, and in this episode we're going to build upon our understanding of all the log laws, which I have written to the right, okay, and implement that, and we'll see how they all work in action as I do a couple of examples that are up on the board. Okay, so let me start off with this one here. This one's a fairly simple one. Log a to the a cubed. See how you got a to the cubed? What can we do with this cubed? We can bring it out the front, just like we did in this log law. So we take the cube out and bring it out the front. So it equals to 3 log AA. And what does log AA equal to? Log AA equals to 1. So it's 3 times 1, which is just 3. Okay? Cool. So that's that one there. Let's try this one here. Log 6 of x equals to 3. Log x to the base 6 equals to 3. The way we do this question here is we rearrange it back into index form. That would probably be the best thing. So if we bring that to index form, the base is 6, the index is 3, and that leaves us with the exponential result, which is x. So x would equal to 6 cubed, which is 216. Okay? This one would be very similar. Alright? Rearrange it as an exponential, right, or as an in index form, and things will become a lot clearer. Alright? So for example, it would be x to the power of, the index would be 2, which gives you 81. So what squared gives you 81? X equals to the square root of 81. X is equal to 9. So let's have a look at the top one, okay? Because the top one's going to be very interesting, as well as E. Alright, so A and E are going to be very interesting. It kind of is an elaboration of question B, but let's have a look at how we might approach question 1 or question A. Alright, so we've got log 1 over 128 to the power of 4, which basically is this, right? What we have is this minus, so this 1 over 128 means that the whole log will be a minus log 4 to 128. Does that make sense? And we use this log law here, alright? The next thing that we do is we work out 4. Does 4, yeah, 4 doesn't really give us as a power, 4 to the power of anything doesn't really give us 128. But they're both powers of 2. Do you see that? They're both powers of 2. So what I would be tempted to do is go negative log 2 to 128 is equal to log 2 of 4. And what I've done is I've used the change of base law. And 2 to 128, that's 2 to the power of 7. Just trust me on that, it is 2 to the power of 7. So it's minus 7 on, and then 4 is 2 to the power of 2. So it's minus 7 on 2 would be your answer for that one. We'll do E, alright, which is another very similar to A. So we've got log 4 to 0.125. Now 0.125 is the fraction 1 over 8. Okay, so what we've got here is log 4 1 over 8. Now 1 over 8 would be the negative log of 8. Alright, so we've got negative log 8 to the base 4. Got that? Now they're both powers of 2. Yep. 4 is to the power of 2, 8 is to the power of 2. So we'll use the change of base law here. So it's log 8 to the base 2 over log 4 to the base 2. Got that? And that gives us minus, and 2 to the power of 3 is 8, and 2 to the power of 2 is 4. So it's minus 3 on 2. You got that? Alright, let's go over to the other side now, and we'll try doing some of these ones. Alright, now with these ones here, there's a number of ways that you can do this. The first thing that we can do is combine these two logs because we're adding the logs. They both have the same base, and so we can combine the logs by multiplying the exponential result. Yep. You can multiply the exponential result, or the other thing that you can do is work this out separately, work that out separately, and add them together. Now, 2 to the power of 4 is 16, so this is 4, equal to 4, plus 2 to the power of 3 is 8, so it's 4 plus 3, which is 7. Okay? So that's 7. This one here, you've got log a to the 8, log a to the 2. This is actually the change of base law, this one here, in reverse. Where you've got a common base and you're dividing, you can work backwards and make it into a common log, into one log, where you change the base to the exponential result of the bottom fraction, the bottom number, and you put the log to the top number. So what you've got is log 2 to 8. And we all know that log 2 to the 8, we've just worked it out in this example, is 3. Okay? And I'll do one more example, just so that you get the hang of it. Alright, log 3 to the 54 minus log 3 to the 18. We can use this log law in reverse, right? So if you're minusing two logs with a common base, you can just divide the exponential results. Okay? So what we've got here is log 54 on 18 to the base 3, right? Which is log 3, 3. Yep. And log 3, 3, we know from our log identity, this one here, is 1. So there's some examples that I've done. I know I've probably done the examples a little bit quickly, but have a look through this at your own pace. They all coincide with the log laws here, so I'll just stand over to the side and just make sure that you're aware of how we've actually manipulated these log laws, okay, to answer these questions. I'll be giving you a couple more examples shortly, okay, so in the next episode I'll be doing a couple more examples, but in the meantime, have a look through them, and thank you very much for watching.